The oil palm is a plant native to hot tropical regions and is found in Colombia, the largest producer in Latin America and the fourth largest in the world. Elias guineensis, as it is scientifically known, is a perennial crop, which means that it can bear fruit for more than 25 years, reaching heights of approximately 13 to 15 meters. It is considered the most efficient crop in oil production per hectare per year, giving up to 6 times more yield than soybean, sunflower and canola. Its production and cultivation process requires a correct selection of seeds, careful planting procedures between nurseries, and in the field, optimal soils and constant irrigation that allow the palm to grow healthy bunches of fruit that will later be transformed into finished products such as cooking oils, margarines, soaps, makeup and fuels such as biodiesel, which makes it present in almost all the products we use every day. To better understand this process, we traveled to the extraction and transformation plant of the Oleo Flores business group, located in the municipality of Agustín Codazzi in the department of Cesar, in Colombia. To this place, which has a capacity of 45 tons of palm fruit processing per hour, the bunches are taken, once harvested at a state of maturity suitable for oil extraction. The fruit arrives at the extraction plant in different types of vehicles: trucks, dump trucks, tractor trailers, or foxes. The vehicle arrives at the company, is weighed on the truck scale and goes to the fruit reception area. In the fruit reception area, these vehicles are unloaded into a hopper. The fruit is stored in the hopper and then unloaded into wagons. The wagons are like train cars. The fruit is stored and the wagons are filled, and we proceed to sterilization. In sterilization, we take the raw fruit that comes from the crop and cook it. We cook it using saturated steam. The main objective of sterilizing the fruit is to soften the pulp to be able to remove the oil that is inside the pulp. Once we have cooked the fruit, we proceed to vacate the wagons that we had previously filled. This is done in an equipment that is called a tumbling drum. Once we vacate the cooked fruit, we proceed to go to the fruit crusher. The function of the crusher is very simple. We want to separate the seeds of the bunch from the bunch. Then in this part the process is divided into 2 streams. The rachis here at Oleo Flores is taken to a rachis plant where we press it to remove the liquid part and obtain a pressed rachis with a lower humidity. This pressed rachis is taken to our composting plant, where we integrate it with the effluents of the complex to make an organic fertilizer or compost. We are currently at the composting plant and the oxidation ponds of the company Oleo Flores SAS. To these areas is where all the solid and liquid waste from the palm oil extraction process arrives, among which we mainly have the effluents that are the liquid waste that you see here. We can see that these are waters that are highly polluting, and if they do not receive prior treatment can generate a negative impact on ecosystems. We have different stages of the process, after passing through the area of the oxidation ponds. We carry out an anaerobic treatment in which we use a lagoon area made up of 8 lagoons, in which different stages are carried out until the organic load of the effluent is reduced and the water is stabilized so that it can be reused either for cultivation or for irrigation of our compost. As I said at the beginning, initially here we also receive all the solid waste from the extraction plant. Mainly and in greater volume what is generated is the rachis. The rachis is the fiber that normally holds the fruit. After we arrive at the shelling process in the extraction plant, we extract the fruit and we have this amount of fiber that is mainly composed of hemicellulose, lamina and cellulose. Also in the part of the fruit, the one that contains the oil is the fruit. It is composed of a fiber, mesocarpal fiber, which is what we have here and are the main raw materials that we use for the preparation of our compost. We also have the filtering soils that are obtained after the process of oil bleaching in the refinery part. We in the composting process, what it consists of. We make these piles that you see in the background, in which we make a proportionate mixture of all these residues that will depend strictly on how they are generated in the industrial process. These materials are arranged as you can see, and they are provided in some piles that are like a row that have a certain height and a certain amount of material that goes according to the capacity of a turning machine. Initially we receive the rachis. You can see at the bottom we receive the rachis. With the help of the loader we begin to form the row that has approximately a capacity of 100 tons. In each row we can put up to 100 tons of material, rachis. To these 100 tons of material we add 25% or 20% depending on how it is generated in the fiber extraction plant. And we are adding approximately 5 or 3% of exhausted soil also depending on how it is generated in the extraction plant. After we have that, the pile already formed with all the ingredients has an approximate weight of 130 tons of compost, of material to compost, pre-compost. In this process we begin the hydration of the piles. How we hydrate it. In the first stages we use the raw effluent. When the pile is in its intermediate stages we use the sludge that we extract from the bottom of the lagoons, and with this what we do is to take advantage of everything that is generated there to enrich this material and take it until we have a finished product, which is a totally fine compost, totally stable, with high agronomic value that can be and normally is used in our plantations. Well, after the pile is formed in the composting lot, we have to incorporate oxygen. This is an aerobic process. It is carried out through microorganisms that work based on oxygen, and we need to add air to the pile. We need to add air to the pile. We do this with an aeration machine that allows us to turn the pile frequently. The purpose of this turning is to improve the granulometry. To go from this rough fiber we have to have a product with a finer granulometry. We also incorporate oxygen and help to prevent the humidity from turning the pile into an anaerobic material and generating rotting, so that bad odors and an excess of flies, etc. At the end of approximately 90 days of process, we obtain a compost product which we submit. We take it to the stockpiles, we keep it, we store it, we dry it, and that allows us to take it to use it in our own farms. Normally we are producing around 1,500 to 1,800 tons per month. Everything will obviously depend on the process flow generated by the extraction plant. We go back to the fruit crusher. In the crusher on the other side we already have the fruit. This fruit is taken to the next stage of the process, which is the digestion and pressing. In the digestion, as its name indicates, what we want is to digest the fruit. Imagine that this is like when you make a juice at home and put it in the blender. It is the same process, but in an industrial equipment called digester. Once the fruit is digested, we put it to the pressing. The pressing here is done in a double screw press, where the press takes the pulp, presses it and removes the liquid part. Then here the process returns and is divided into two streams, one the liquid part and the other the solid part. The solid part is composed by the fiber and the nut. The nut is the seed of the fruit. That stream is separated through a pneumatic separation column, which is a column through which passes a stream of air. The air stream is separated through a pneumatic separation column, which is a column through which an air stream passes. From that air stream the lighter phase is taken to the top, which in this case is the fiber that ends up reaching the boilers, and from the bottom we have the nut. The nut goes to the pulmisteria process, where we try to recover the kernel that is inside the nut. Then, the kernel is taken to a sorting drum and then we pass it to a 1000 rifle type breakers. The breakers break the kernel. By breaking the kernel we can free the kernel and separate it from the shell. Again we make a pneumatic separation. We remove the shell from the mixture and we take it to the boilers. Our boilers are fed with both fiber and shell, and we store the kernel, dry it and process it in our speller plant. In the speller plant what we are looking for is to remove the oil that the kernel has, as crude palm kernel oil. Then here we obtain two products. One is the crude palm kernel oil contained in the kernel, and the other is what is left of the kernel when we remove the oil, which is the palm kernel cake or meal. We go back to the presses. We have already gone through the solid part, which is the fiber and the nut, and we are left with the liquid part. What is the liquid part that comes out of the presses? Is a mixture composed of crude palm oil, water and sludge. We have to separate the sludge and water from the oil. How we do it? We take it to a process stage called clarification. The oil clarification starts with a static separation in tanks where we let the mixture rest. We subject it to a temperature of approximately 80 degrees Celsius to 95 degrees Celsius, and as oil and water are immiscible substances they will separate. Then here three layers are formed: the oil, the sludge and the water. Then, when we let it rest, we can remove the oil from the top and the sludge from the bottom, as these sludges still have an important oil content. We take them to a dynamic separation because the static separation is not enough to remove all the oil from the sludge. This dynamic separation is done in equipment called deloging centrifuges that, as its name indicates, use the centrifugal force to separate the oil from the sludge. Once we are sure that the sludge does not contain oil, the sludge leaves the process as the final effluent of the process and goes to the composting plant. The oil still needs one more process to finish cleaning it, which is a drying process to reduce the humidity, and a sedimentation process to remove any impurities it may have. With that we deliver a crude palm oil free of impurities for further processing, which is the transformation process. Once the crude oil is extracted at the extraction plant, it is stored in tanks provided for this purpose and the transformation process begins. At this moment, the Oleo Flores plant has four important transformation processes: physical refining, fractionation, biodiesel and margarines. In the refining process, what we try to do is to eliminate the compounds that are seen and not seen in crude palm oil. Among the compounds that are seen are what are called impurities, and those that are not seen we have the mucilage gums, metals and other elements, and under a process of steam dragging in high temperature all the beta-carotenes are removed. All the impurities, all the acidity, and the crude palm oil turns from a red color to a greenish-yellow color, and that is the final oil that we have as RBD oil. It is the refined, bleached and deauthorized oil that is the raw material for the production of biodiesel, the raw material for fractionation and raw material for margarines. The process subsequent to refining is called fractionation. Palm oil has the particularity of having two phases, one solid and one liquid. The liquid phase is called olein and the solid phase is called stearin. Then we take the RBD oil and we take it to controlled temperatures from 65 to 70 degrees Celsius to 18 to 17 degrees Celsius, forming crystals. These crystals then pass, or this oil passes through a filter, that is, the liquid mass becomes a little pasty, and under pressure, the oil is pressed and the crystals are broken. And we obtain the liquid phase and the solid phase of the RBD oil. Olein is normally used for packaging and stearin can be used in packaging processes, margarines, biodiesel, among others. The liquid phase, as I mentioned a moment ago, is the olein, which is the common vegetable oil that we see in any kitchen in Colombia or in the world. It is the edible oil that can be mixed with soybean, with other types of oil, and the stearin that is also the basis for making margarine, for mixing with other RBD oil, palm kernel, RBD oil, and there are other fractions of stearin that are used in cosmetics. In the manufacture of ice cream, infinite uses for palm oil. It is estimated that the palm oil sector generates approximately 180,000 formal jobs in Colombia. The country is currently at the forefront in the quality of oil production, and its future looks promising due to its geographical position. That is why its bed is aimed at improving the quality of the transformation processes, and to venture more strongly in the field of natural fuels such as biodiesel, which allows to approach more easily to domestic and foreign markets. Our product has many outlets. Our product is a wild card. Our product is a fundamental raw material in the food line. It represents a very important advance for farmers, because we guarantee the purchase at a very competitive price of their product, and we process it here. The market still has a lot of space to continue receiving the products we have, and we have the possibility of selling it both nationally and internationally, because the crude oil is used in the transformation processes to convert it into final products for customers. And we also have the possibility of selling it abroad through exports. If you analyze the national context, you see that new plants are opening at national level, here in the north, in the central zone, If you look at the countryside, every day cars are leaving the nursery. With plants, people are convinced that we have to plant, that we have to grow the crop, so it is promising, both the crop and the plants are growing, and as I said, the national market still fits. It still has possibilities to sell the products we have. We have this plan, but we also have the other plan, the export plan. We export to Europe, we export to Asia, so the crop is growing. The industrial part is growing and the market still has a lot of space to put the products we have.